Okay, so we are going to go on to 7.2.2, and now we're going to learn the actual method on how to use U-substitution to integrate the chain rule. So to start off this lesson, we're going to talk about two basic integrals, and we're going to think about what is our method for trying to do this with a shortcut. So for our first one, we're going to think about which is the function that we start off with. Does this one turn into 6x squared, or does 6x squared turn into x cubed? Well, if we start off with the derivative of this one, the chain rule will allow us to get 6x squared. So we'll start off with x cubed plus 5. Notice that I have this to the first power, which means this needs to be squared. That way, if I square it and take the derivative, then it'll go down to the first power. Which means that if I take the derivative, it will have a 1/2 in front of it. So if I was to take the derivative, it will have 1/2, and then I multiply this by the chain rule. The derivative of x cubed is 3x squared, 2, and that will allow us to get 6x squared. Therefore, we are done. This does not need any coefficient. For the second one, think about which one turns into the other. X to the fourth will turn into x cubed, so therefore that's the function we're going to start with. We have a negative 1/2 power. If we subtract 1 from what makes negative a half, that becomes a half. And now we need to think about, if I take the derivative of this, this will put a 1/2 out in front, and I don't want a 1/2, I want a 3/4. So also the derivative of the x to the fourth will become 3x to the third, which means that I'm going to say what times 3/4 will give us 3/8. And that ends up being, or the 1/2. So that ends up being 3/8. So we're going to put a 3/8 here. And we're going to put plus c. These two integrals are actually quite easy. However, the integrals we're going to look at next are going to require a certain method. This is the method. I suggest that you spend the time to look at this method, but I'm going to go through the method through the two examples that we have below here. So I'm going to do A and B, and I want you guys to do C and D before you scroll down and look at the answer for those. So the way that we're going to do this integral, let's write down our integral first. You can actually do this one really quickly through the method above. However, I'm going to go through the actual steps on how to do this. So the first thing we're going to do is decide what are we going to U-substitute. And it's usually the thing in parentheses. So that is what we're going to say equals U. So U equals x to the fifth. Next, what we're going to do is we're going to take the derivative of this. So we're going to say du with respect to x over dx equals 5x to the fourth. Now, I have a dx in here, so I'm going to solve this equation for dx, which means I'm just going to switch these two. So du over 5x to the fourth equals dx. Now, since this equals dx, I'm going to substitute this into our original equation. So I'll say the sine of x to the fifth, x to the fourth, du over 5x to the fourth. Next, what I'm going to do is I'm going to replace my x to the fifth with u. So now this says sine of u, x to the fourth. Well, we have an x to the fourth and x to the fourth. They're going to cancel each other out. So we'll say this is du over 5x. Oops, sorry, just 5. So now we're going to, or really 1/5 du. So now we're going to integrate. So what is the integral of sine, or 1/5 sine of u? And that will be cosine u times a fifth. But its negative cosine turns into sine, so it'll be negative. And it'll say plus c. because we have an indefinite integral. Next, we are going to replace u. U is x to the fifth. So our final answer is -1/5 cosine x to the fifth plus c. I'll do this one more time for the next example. We have the integral of -3x to the fourth plus 2 to the fifth times x cubed dx. So we need to determine what is u. It's the thing in parentheses. If I took the derivative of this, it turns into x cubed, so therefore that's u. U equals -3x to the fourth plus 2. We're going to take the derivative of this with respect to x, -12x cubed. We're going to solve for dx. We're going to replace this with dx in our original problem. We are going to replace this with u. We're going to cancel out the x cubes. Divided by -12 du. We are going to integrate u to the fifth, turns into u to the sixth, times a sixth, times a -12th plus c. So that's going to be -1/72 u to the sixth plus c. We are going to replace u. Oops, that's not u. U is that one. Sixth plus c. Okay, so why don't you go ahead and pause it and attempt to do C and D in the same way that I did those. I'm going to assume that you pressed play now, and here are your solutions. Let me know if you have any questions. I'll see you later on today, and here is your assignment. Just 3 problems.